we're joined by CPS's Vice President of Business Development, Albert Medoro, to talk about why processes that work in the lab often fail when scaled to production. So Albert recently presented on this topic at SOCMA show. So we're excited to dig into some of the insights behind one of the biggest challenges in manufacturing and how companies can avoid related pitfalls. So thank you for being here, Albert. So before we get going, can you briefly tell us about your role here at CPS and what your day-to-day looks like and how does scaling kind of fit into this?
Thank you for having me. I appreciate being on here. So I run the sales and process development teams at CPS. And that really just means that I spend a lot of time on the phone with the sales reps and the technical team with companies who have a process, works great in the lab, and now they just really need to figure out a way to make it into real volume. So we do a lot of different things, but our core competency is milling. It's where we started and where we go deepest. Scaling in terms of a pilot up to a production is a touching conversation. Even when someone calls and tells us that they're ready to go right to production, there's always almost something that we have to pressure test before we get there. And again, that's the nature of the work, but we can't really just take the customer's word that they're ready to go. We need to run that scale up trial.
So most processes don't fail in the lab. They kind of fail when you try to scale them. So you probably have seen this firsthand. So at a high level, why is scale up such a risky stage in manufacturing, you think?
I think it's just because not all of the processes or the products are going to be able to scale proportionally. It would make our job a lot easier if everything scaled proportionately, but it doesn't actually happen that way. You have your processes that run perfect on small equipment, but as soon as you try to move that to a bigger vessel or a bigger mill, all of those different variables start to come into play. The material flows differently. The residence time in those larger mills is different than what it was in the smaller mills. Um, your equipment's bigger, but the physics inside of the mill don't necessarily change. So your margin for error really gets a lot tighter. In the lab, you have a wide operating window and everything may work fine, but that scale really shrinks once you move that up to the production side. Your feed rate's going to make a huge difference. The distribution that you're looking to achieve is going to matter more. And all your parameters obviously are going to have that much of a bigger impact than they would on a feasibility or pilot scale.
Interesting. So from your experience, where do you see companies tend to underestimate the complexity of scaling a process?
It's in the equipment. That is the one that really catches people off guard when we're having the conversations with them. Um, Sometimes the assumption is the mill, dryer's a dryer, but that's not the case, right? We could say we've run it through a pancake mill, or we have a process that we ran quickly through a hammer mill. But then when you take a look at the spec sheet, a D50 under 10 microns with a really tight distribution, that's not a hammer mill job. That's a jet milling job, and it's a pretty complex jet milling job, right? So if you're not able to spot that early, you're going to build a process around equipment that is not ideal and it's not going to get you there. So I think it's extremely important to vet those details out in the beginning. And then the last part of that is that most companies are going to run their mills to the OEM standard. And that is certainly going to get you to a point. And that's going to get you to a point when you're running one product, millions of pounds over and over and over. But there's a whole range of performance that you really can unlock if you run it outside of parameters and beyond standard, because you have to take learnings from all of the different products that you've run and start to combine some of the similarities to really outperform what the OEM standard is.
Hmm. So when companies move from lab to production, what are the biggest challenges they don't fully anticipate? Like I'm kind of thinking along the lines of material behavior or flow characteristics, equipment limitations, and so on?
Yeah, material behavior is definitely a huge part of it. You could run a very small trial, and the material is going to flow through that hopper very easily. And when we say small trial, we might be talking 1 kg to 5 kgs. But as soon as you move that to a pilot or a production, you're changing all the dynamics. You're not top feeding something, you're running it through a screw conveyor from the floor, and you're taking that up 20 feet. All of a sudden, that's a much different process than it was when you were running it on your benchtop scale. So what would have moved very freely in that feasibility state has now become probably the hardest part of the whole process. And you wouldn't think that, right? You would think it would be hitting that tight particle size distribution. Um, and then on the opposite end of that, it could be just packing it out, right? In the feasibility, you're packing it out into a 1 kg liner that somebody is just testing, right? They just want to make sure that it works and it's feasible in their process. But now when it's in commercial, you got to pack it out into a 55-pound valve bag, and all of a sudden, that's your biggest constraint. So I think you hit it on the head with material flowability, because that's a huge, huge player in that constraint.
So, where would you say is the most commonly seen processes that start to break down? Do you have any types of examples that you can give us?
We talked about material flowability, but there's also the whole idea of yield. Your yield on a pilot and a feasibility are going to be much higher than they are in production. You could go from something in a lab scale that's at 98, 99%, and all of a sudden you move to production and that turns into 84%. Some companies can manage that, but most companies can't. So that margin will catch up to you pretty fast. We had an example that I like to share of a customer that came in with a validated process. And from a technical side, it was very sound. It worked in their application. But commercially, there was no way it was going to be able to meet the market expectations. That the cost was just way too high. And the only way we were going to be able to get to a price that was going to be viable for them was to considerably collapse the whole process and just take it from three down to two or one. Um, so companies have to be open to that, right? Because we have experience and we know what the anticipated throughputs are going to be. So in this particular example, company was not really open to paying that extra money. So we kind of just took it upon ourselves to run it on our dime, because we knew at the end of the day, once we provided them two side-by-side samples delivering the same exact performance from their side at 50% of the cost, it was going to be a no-brainer. And that product's been a huge success for us. And that's what we're trying to do with this scale up process, is we're trying to replicate successes like that so we can continue to build the product portfolio.
Awesome. So, the next topic I kind of want to talk about is some misconceptions and some common risks that you see. So, do customers kind of underestimate just how nonlinear scale ups can be? Like, because it's not always point A to point Z.
Yeah, so we get a lot of customers that are going to call and say, we went from 1 liter batch and it worked, so we want to try a 100-liter batch. And theoretically, it should work, right? But it doesn't always scale that way. You have a lot of different constraints once you hit these different scales. And I keep going back to milling, but it's just a really good way to explain this. You may get a perfect grind off of a small scale jet mill, but as soon as you go to push that rate on a production jet mill, you run into all these different issues that you need to anticipate, but you probably didn't from the beginning. So all of a sudden, your mill's processing very quickly, but you're not feeding at the same rate as you would have been during the feasibility scale, right? Your particle size swings now start to be much greater than they were during the feasibility state. And again, it's just these are the things that happen, and if you don't deliberately try to impact it and make that happen during the pilot stage, you're going to cost yourself a lot of money once you go to production. So that's why we really adamant about, if you have the ability to run a pilot, let's run a pilot before we go.
So that kind of goes into my next question here. So, how common is the assumption, that what works in the lab scale will translate directly to production scale?
It's the most common assumption that there is. And sometimes, I'll be very honest, we'll lose work because we're not willing to take that risk. Um, because we know, you can't predict what you can't predict. And you're talking about different equipment, different batch sizes, different feed systems, and a high probability is that when a company comes in for immediate production, unless it's something that we have absolutely done and we understand and we've trialed it with other customers or other like materials, we're going to push for that pilot because it's going to create such an advantage for us when we go to the production size.
And what about pilot trials? Do you think companies kind of fully understand how critical they are, or is that something that gets overlooked?
It absolutely gets overlooked. And I think it gets overlooked because pilot trials cost money and time. I think everybody can get behind a feasibility trial and spending the money on a feasibility trial because it's absolutely critical to make sure that it's even a viable process, right? So I'll spend money to make sure that I actually have a sample that I can send to a customer and it will work. Now I'm ready to go sell it to the market, but you're telling me I have to run another trial in the middle. That's going to cost me more money. Well, that's a tough pill to swallow for some, but the pilot is where you catch all of the things that are going to happen in production. Material buildup, wear patterns on the equipment, just inconsistencies in the feed rates. And that's where our technical team will actually they will try to fail. They will try to emulate those things that are going to happen in production because they want to move on to the next product, right? They want to move on to the next trial. They don't want to have to repeat this trial. And they also don't want it to move to production and then come back to them as a failed trial because they didn't anticipate these issues.
So, what's something customers feel confident about going into scale up that often turns out to be incorrect?
In the toll processing world, the term milling is used very freely. Um, and there are so many different types of mills out there. So when we're talking about you were able to hit a spec at scale with this piece of equipment at a lower throughput. Once you start to scale that up and your throughput starts to rapidly increase, you can't necessarily run the same mill type unless you have every single mill type at every single stage of the process. So it very well may have worked on your small Cuisinart kitchen grinder. Um, but if we're going to try to emulate that on a production scale with a hammer mill, that's not going to translate into truckloads of material, right? You need to be able to be flexible enough that particle size swings have to be able to be attributed to a different technology.
So, let's kind of talk a little bit about the business side for a minute. Have you seen cases where a process technically works but still isn't viable at production scale?
Oh yeah, all the time. This is a very common thing, right? Because your process is going to work and you can hit the specs, but at the end of the day, cost is everything. And unless this is a unbelievably specialized product that only one company can provide, there's always going to be an alternative. So there's oftentimes that customers are developing a process, they have an idea, they have one material that may work, but it won't be economically viable. But they'll try another material and then maybe another material. And you may lose some performance on it, but it's not enough to offset the actual market value of the potential. So you could have three or four iterations of the same process, and that third or fourth one is the one that can actually scale and become economically viable from a business perspective.
So, what actually makes it not viable? Cost, yield, throughput?
It's a mix of all of them, but typically it's throughput. In milling, in particular, you can usually get over a yield because you can recycle material, right? Especially if you're looking for a fine particle size. So yeah, the yield itself first pass may not be the best, but you can recover it. But in order to recover it, you're adding that additional mill time. Whereas if you just had the throughput and that yield from the get go, you'd be in a much better situation. But throughput drives yield, right? There are instances where you're trying to hit a throughput rate that's going to be viable in the market. You hit that throughput rate, but now all of a sudden, in order to hit that, you've sacrificed 15, 20% yield. So now where's that sweet spot in where you have to adjust your throughput to either speed it up or slow it down to recapture that yield? And that's why the feasibility and the pilots are so important, because you're working with 10, 20, maybe 1,000 kgs instead of 20 to 40,000 kgs with two trucks.
So, now that we kind of covered some cautions, let's kind of focus a little bit on the other side. When scale ups go well, what does that process kind of look like?
The best scale ups, I think, from our side always happen on the processes and the trials that go through all three steps. And we call it the crawl, walk, run model. The crawl is the feasibility. So we got to make sure that it works for you. The walk is then it works. Can we do it for a price that it's going to work? And then once it works and it's commercially viable, that's when we'll look to run it in production. That may ultimately turn into that commercially viable product. Um, the projects that go well are the ones that go through each one of those steps. And it's not to say that every single one has to go through those steps, right? If you have experience and you have similar products in your library that you have knowledge about, you can afford to skip one of those steps, right? You may be able to skip the feasibility because you know that you can do it. Now it's just a matter of can we do it for a good cost. But the ones that hit every one of those stages, they tend to be the ones that bring the most success to us and our customers.
Mhm. So, what roles do feasibility testing and pilot trials play in reducing that risk?
I mean, the feasibility is going to confirm you can do it, right? In that feasibility stage, you're not necessarily trying to perfect anything. You just need to know, is this something that can be done? Um, we oftentimes will even go as far as to keep the cost down on a feasibility, we'll run what we call a dirty trial. And that just means that we know that any cross contamination is not going to affect the performance of the product, but we need to know whether or not we can hit the particle size that's going to be optimal for the customer. So keep the cost down there by just providing a particle size report that says, yes, we can do it. By doing that, you're keeping costs down at that first stage, which then allows you to free up some budget for that middle pilot stage, which is definitely more rigorous. Because from there, you're testing all of the issues that are potentially going to occur. And the pilot is where you need to run multiple batches, right? You can't just run one and assume that you have enough data to provide a commercially viable cost. You could run for 12 hours versus 6 hours. Your humidity could have changed. You could have an issue with a feed rate just drifting. And if you're not capturing three different runs and three different batches, you're going to leave yourself open for some potential downfalls.
So, where do tolling partners, like CPS, kind of make the biggest difference in the scale up process?
I think it's just in recognizing the patterns and having the knowledge of multiple products and multiple processes instead of just one core product and process. Tollers are very adept to changing over, right? They're not running one product around the clock. That is the ideal state, right? You want to get to that point. But most of the time, you have to be flexible, and tollers know over time which raw materials are going to behave differently than others. And you don't always get that with your internal team, right? Especially like a procurement team that's just looking to maybe get some cost savings by swapping out like materials. You may save a couple pennies on the price per pound, but the effects that it has on the process could be substantial. So a toller is going to get out ahead of that and understand that there's big differences in those products that are substitute products.
So I'm kind of curious then. So when a customer is preparing to scale up a process, you know, what are a few things that they should be kind of thinking about right away?
They should be really identifying their critical constraints. So is it throughput? Is it cost? Is it purity? If they can identify those right from the get-go, it makes everything a lot easier because you're not going to get everything perfect. You're not going to check every single box off the first time. Um, and the ones that are maybe a little less critical to the performance, those can be tweaked down the line. But if you start trying to check off every single box from the first trial, you're going to set yourself up for just time and money. And again, there's a long process to get things commercialized. So anything that you can do up front and provide is critical and will really help streamline the whole process.
So when do you think they should bring in outside expertise to kind of avoid the potential issues?
I mean, ideally, it would be during feasibility. There's different thought processes there, but if you're bringing it in after and you're bringing it in during crisis management mode, that's not an ideal situation because you're trying to scale something now that you haven't scaled before. If you have a concept, you have an idea, and you haven't spent too much time on it yet, but you theoretically understand that it should work, that's when you really should start bringing in a toller. They're going to be able to debunk any of those anomalies that are going to happen in the process downstream. They're going to be able to weed those out pretty quickly, or they're going to be able to provide you with an alternative pretty quickly and just save you time and money.
So kind of as we wrap this up a little bit, I'm kind of curious about, let's just say, one scale up mistake you tell customers to avoid at all costs.
Don't skip the pilot trial. I know that the costs on a per pound or per kg basis looks astronomical compared to what the production pricing would be, but it's just all economies of scale at that point. I mean, what may cost 10x from a price per pound could save you hundreds of thousands of dollars on a production side. So again, don't look at a dollar per pound price from a pilot perspective. Look at it from the totality of the cost of the product because I'd much rather spend $10 per pound and only produce 100 pounds versus having to be liable for 100,000 pounds at $5 a pound, right?
Yeah. So, I mean, obviously, that kind of goes into this last question. What's one thing they should always do before moving to full production?
I think it's run pilot batches and run multiple pilot batches. Establish repeatability, not just for cost perspective, but also for the performance perspective, right? Um, One successful run could very much just be luck. Three successful runs is repeatable, and that's what you want to strive for.
Well, Albert, this has been great, and I appreciate you sharing your perspective on everything. And thanks to you all for tuning into this episode of Toll Manufacture Minute. And just be sure to subscribe for more insights from our experts like Albert. And if you're kind of evaluating the process for scale up or want to reduce risk in production, the CPS team is always here to help. And we'll catch you next time.